Welcome to Unit 1, Lesson 2, Introducing Geometric Sequences. All right, let's explore growing and shrinking patterns. Okay, here's our warm-up. What do you notice? What do you wonder? Well, if I ignore the 0 and I just look at 4, 12, 36, 108, and 324, how do I go from 4 to 12? I'm not sure. So if you see a bunch of numbers, see if you can add. I know 40 plus 80 is 120, but 120 plus 80 is 200, not 360. Well, how else could I get from 4 to 12? I don't know. But what if I do the number on the right, 120 divided by 40? Wait, 12 divided by 4, I know it's 3. So maybe this is multiplying by 3. So maybe this is multiplying by 3. Okay, so for the next one, 2, 8, 32. Well, how do I go from 2 to 8? If I add 6, 8 plus 6 is 14. But that doesn't get me to 32. So let's try to multiply. 2 times 3 is 6. 2 times 2 is 4. 2 times 4 is 8. What's 8 times 4? 32. So this one could be times 4. Now you have a calculator. You went to the app store in class one day and downloaded Calculate 84. And so I know you all have a calculator in your phone. So for the next one, let's see, I'm getting smaller. How do I go from 1,000 to 500? So you do the same thing here. Take the number on the right, divided by the number on the left, and here you get 0.5. Now, if you don't recognize what this fraction is, if you have Calculate 84, hit the math button. It's at the top left. It's third button down, and hit enter 2 times. Hit enter, then hit enter again. And what the TI-84 will do is take 0.5 and turn it into a half. So that's what we're multiplying by, is a half. And then for the final one, again, I'm not sure how to get from 256 to 192. I know it's going down. So what I'm going to do is do 192 divided by 256. And this is going to give me 3/4. Well, it's going to give you, what it's going to give you is 0.75. And again, here, you hit math on your calculator, hit enter twice. And when I put them in squares, that means it's a button. Math is on the left side. It's 3 buttons down from the top, from the buttons on the left. And then you hit enter twice, and this will turn you to 3/4. Okay, so we did this one in class. If you take a piece of paper and fold it, so, well, maybe you have at home and you have scissors. If you want to cut it, fine. But in class, we folded it. Okay, so we start with one piece of paper, and we're going to say that the piece of paper is 8 by 10. It's 8 going across, 10 going down. That gives us 80 square inches of paper. Okay, so now just follow the list down. So if I fold it hamburger, which means I fold it down, 2, if I open it back up, I get 2 pieces of paper, 2 sections on my paper. My 8 stayed the 8, the long stayed the long, but I folded the 10 side down, which went in half, and now my area goes down. And then now, I folded a hamburger. Now I'm going to fold it hot dog the long way, which means I folded the opposite way of which I folded it before. Then I open it back up, and I get 4 sections of paper. And now my 8 side gets cut in half. And I know 4 times 5 is 20. So now, I'm at a 4 by 5 piece of paper. I'm going to fold a hamburger, which means down. And then when I open it back up, I should have 8 sections of paper. Then I fold it all back down to where it was. And what happens? My 5 side goes down, and that gives me 10. And times 2 here is 16. 2 times 2.5 is 5. And now this may seem kind of funny to you. We are in Algebra 2 now. We're not going to be using the x for multiply anymore. We are going to be using the dots because that is a different way. Let's write 2.5 here. So 2 times 1.25. So if you see the pattern, the number of pieces constantly doubled, the area constantly went down, and it is switched sides. So the first time, the long side went down, then we cut the short side down, and we cut the long side, then the short side, then the long side. So it kept switching every time what got cut out. And take and fold a piece of paper and it'll make sense. Okay, so now we're going to take the data that we just had and graph it. So read the questions. As 0 folds, we folded it. And instead of pieces, we had sections. Please take a piece of paper and fold it and it will make sense. We had 1 piece. After 1 fold, we had 2 pieces. After 2 folds, we had 4 pieces. After 3 folds, we had 8 pieces. After 4 folds, we had 16. After 5, we had 32. And you can see that this is starting to make a graph here. And so now, for our area, we started at 80. After 1 fold, we went to 40. After 2, we went to 20. After 3 folds, we went to 10. After 4 folds, we went to 5. Then 2.5. Then 1.25. And so we have 2 separate graphs. They're doing different things. So let's describe these graphs. So if I had to describe these graphs, I could say that the one on the left is increasing as you go from left to right, the outputs, because we're only worried about the outputs. And it looks like it's making a curve. And the one on the left is decreasing. But it also makes a curve. So both graphs curves. What you could say is that geometric sequences, and I didn't introduce you to the word geometric yet, but geometric sequences make curves or curve graphs, but they make curves. Okay, write that down on your notes. Okay, so now complete each geometric sequence. So when you see the word geometric, write the word multiply and divide, because we know if I divide by 2, that's the same as multiplying by 1/2 because of our fraction rules. If we forget, our fraction rule is if we have 2 divided by 2, that's the same as keep the first fraction. I could put any number over 1. It remains the same number. I change division to multiplication, keep, change, and then flip. I flip the second one upside down, and I get 2 over 2, which gives me 1. So 2 divided by 2 is 1. So dividing by 2 is the same as multiplying as the inverse or the upside down, or multiplying by the reciprocal. It's another fancy word. So now let's look at this. How do we go from 1.5 to 3? Well, how do we go from 3 to 6? 3 plus 3 is 6, but this is geometric. We got to multiply. So 3 times 2 is 6. So that means we're multiplying times 2 every time. So 6 times 2 is 12. 24 times 2 is 48. So our growth factor is called times 2. Growth factor is the change in the geometric sequence. So it's the change in a geo sequence. Okay, 40, 120, 360. We saw this in the warm-up. I think this was 108, 1080, and 3240. And the change is times 3. 220. Now, the funny thing about zeros is you see the zeros disappearing as you go to the right. So all numbers have a decimal point at the end. And if you move the decimal point left, that's the same as dividing by 10 or multiplying by 1/10. And so the next number is 0.2 and the next number is 0.002. How do I know that? Whenever I divide by 10, the imaginary decimal at the end of every number that you don't see moves left 1 spot. Okay, so D is kind of hard to see. So if I write it out again, I should probably change the colors, but 1/7, something 7, 9/7, 27/7. Okay, so how do I get from 1 to blank to 9 to 27? 9 times what number is 27? 9 times 2 is 18. 9 times 1 is 9. 9 times 3 is 27. Oh, times 3. What's 1 times 3? 3. So this one is 3/7. And then 27 times 3 in your calculator is 81. So the change here, or the growth factor here, is times 3. And now for the next one, 2412. 6 times what is 12? Because we're geometric. We're not adding, we're not subtracting. That's not a geometric sequence. Divide by 2 or times 1/2, and then 3, and then 1.5. Hey, well, look, that looks like the one up there. They just gave us the same sequence backwards. Okay, our lesson synthesis is an activity we can do in class. Okay, can you find missing terms in the geometric sequence? Yes, you can. So whenever you see the word geometric, we multiply or we divide. Geometric sequence is a sequence in which each term is a constant times the previous term. So let's say I got 2 and I multiply by 2. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So times 2, the times 2 applies to each term in the sequence. A geometric sequence multiplies the same number to each term.